All right, I wanted to do one more application. The last one was compounded continuously. Now I'm going to use the same information and compound it monthly, just so you can see the difference. So when you have a compounding, just a general compounding problem, you're going to use this formula. Okay, so there's our compounding formula. We're going to plug the values in where we need them to go, and then we're going to solve. So again, how many years will it take to grow 10,000 to 25,000 if it's invested at 7% compounded monthly? So we want to go up to 25,000. That's what we want to end with. We're starting with 10,000. 1 plus our rate is 7%. Our number of compounds is 12. We're raising it to 12 times the time because we don't know what the time is. We don't know how many years it is. That's what we're looking for. All right, now this one is a little bit more complicated than the continuous compound one, but not so bad, not too bad. So again, first thing I'm going to do is divide off my 10,000. So the goal is to get that t by itself. So what I'm going to do is I'm going to start peeling things off. Okay? So 25,000 divided by 10,000 is 2.5. I'm going to go ahead and calculate what's inside my parentheses because that's a number. I have all the information I need. So 0.07 divided by 12 plus 1. So inside the parentheses, I have 1.005833, all raised to 12t. Okay, so now you notice there's no e. But the good thing is because I'm undoing things, as long as I undo the same technique on both sides of my equal sign, it doesn't change the values. So I can ln both sides or I can log both sides. It really is up to you. I just prefer ln. It's just what I always go to. So even though I don't have an e, I can still do ln of both sides. Okay. It doesn't eliminate the e because there is no e. So it doesn't eliminate this like it does when we're using the continuous compound interest. But what it does do is when I ln this, I've just changed this to an exponent. So now I have an exponent on an exponent. I'm going to use the power rule. So on this side, I have ln 2.5. This side, I'm going to drop my 12t to the front and then multiply. Okay, so when I ln, what I'm doing is it allows me, because now I changed this to an exponent, I have an exponent on an exponent, and when you have an exponent on an exponent, you multiply. So I drop that exponent to the front and multiply. So now the goal is to get t by itself. So first step, I'm going to ln both sides. I'm going to divide both sides by ln. So on your calculator, you're going to do ln 2.5, close the parenthesis, divided by ln 1.005833, close the parenthesis. So this gets calculated to 157.545. I still have 12t on the other side. And then I'm going to divide both sides by 12. So my time is still 13.128. Okay, so if you remember the last one when we did continuous compound, it was 13.028, I believe. This time it's 13.128. So because it's compounded monthly, it's going to take me just a little bit longer to be able to grow my money from 10,000 to 25,000. Okay, and that's it. Katie,